Hello creative coders, this is a video where I'm going to be talking about some time functions in p5.js and some ways you can use the map function to visually display that time in ways that are interesting and aren't just a matter of reporting the time as a number. This is an assignment for my students. Anyone else obviously can watch this because it's on YouTube, so whoever you are, I hope you find this helpful. I've turned up the audio compared with my last video, so hopefully, because I noticed when I listened to the playback that I could not hear it at all. So now hopefully it's maybe audible, but not too loud. We'll see how that goes. I'm keeping an eye on the little sound meter thing as it goes up. So in today's video, this current video, it's not the first video I've recorded today. I do want to cover three things. I want to talk about the time reporting functions. There are several. I want to talk about the map function because it's really important even if you're not doing stuff with time. It's a super cool function. It's super useful for so many interesting things. And then I also want to talk about the weirdness of millis or milliseconds. And I guess what's weird about that slide is that the W changed on that one. That was the weirdness of W's in the word weirdness. Because there are several time functions that are related to other units of time, seconds, hours, minutes. However, milliseconds or millis is different, and we have to do a few things if we want to make it act like the other ones. And I'll try to talk about that in this video as well. So to talk about it, I'm just going to use the p5.js editor in p5.js.org. This is a sketch that I'm just going to use to demonstrate a few things. I'm not making a project here, so hopefully that'll be okay, and hopefully it'll show up pretty clearly here. So time, what is time? So the way that JavaScript thinks about time has to do with the date function, which you can access. Hopefully, is that visible? It's not quite visible, is it? So I'm just sliding this up here a bit. So the time function is something you can access as part of the date object, which is just an inherent thing in JavaScript that's just always there when JavaScript is running. And right now it's reporting this timestamp, which is 1685597291280, which is the number of milliseconds that have elapsed since midnight on January 1st, 1970. Number of milliseconds, and that's going to obviously be a different number every time you run it, basically. So because there's 1,000 milliseconds per second, so it goes by really fast. So that's something that obviously humans can't really read and interpret, but there are ways to mathematically derive all the rest of the information about a date from that one number. So that's why it's a useful thing. It's a universal thing. Every computer uses it basically to check in with each other about what the current time is, and then report the current time to the people using the computer so that we can understand it in a way that's more human readable, as we say, more useful. So I'm going to go ahead and set up a couple things on this sketch just to make it a little bit more of a space that I want to work with. Let me go out like that on this one. Slide this. I think I'll just pull that in here. Sorry, just making a few little adjustments, last minute adjustments. It's past the last minute adjustments on my sketch over here, so I can see what I'm doing a little bit better. So this is the draw function, and this is where I'm going to draw a few things here that will report the current time. We'll just start off by doing it in text form. In fact, yeah, we'll just do it this way. So I like having text to essentially debug what's going on with certain things. So we'll just start with, let's start with the hour. And the hour function is just the word hour followed by parentheses. So this is the text function that I'm using to draw this with. I'll just go ahead and do this. The hour is going to be at 50 and then 50. I'm just going to draw that on the screen. Hopefully you can see that on this here. It's kind of small. Let me make it bigger. Hopefully the audio is not too loud. Hopefully you can hear it a little bit. I can hear it coming from my headphone speakers, but I'm not wearing my headphones. But it's that loud on my speakers I can hear it. So hour, well, that's too big. So that's better. So we'll do that, and then we'll go down kind of in increments of the 25. So you'll see what time I'm recording this video at here in a second. That's right, it is 1:30 in the morning. Hour, minute, and then seconds. We'll go ahead and do that one as well. And we also do have the day, we have the month, we have the year. I'm not going to need those for right now because I might use them eventually, but they're not, they're not normally something you would see in a clock, and that's what we're working on here. So that's the, I'm gonna leave those off for now. So that's the current time right now, 1:31 and 7, 8, 9, 10 seconds. Every second it ticks over, and so we can see it going from there. Now, as I mentioned earlier, there is the millis thing, and I'm going to go ahead and show it to you here, but I'm not going to fix it yet. The current milliseconds, which you don't normally actually show the milliseconds in a clock, but you might use it in animation if you're doing something with p5.js. So you want to know what the current milliseconds are with respect to the other things, like how many minutes or how many milliseconds since the last second has it been. And you want to use that information within the draw loop to draw the position of something between 2 points, let's say. So that is something you're going to need to change. However, if you notice something's unusual about this one, if you just saw it here, every time I restart the sketch, it starts at 0. It's because millis actually records the number of milliseconds that have passed since the sketch started running. So it resets every time. And it keeps going up. So right now it's already 12,000, 13,000, and so on. So that's not going to be very useful for me because I need something to change incrementally within a range in order for me to use it in an animation or an illustration. So millis by itself is not going to do much good for me. But let's do something here, and I'm going to disable that one because it's stressful for me to see that one as it goes up. So I'll come back to that and reset it in a way that actually is going to be more useful. So, but before I get anywhere else into that, I want to talk about the map function and really just show you the map function. So first of all, I'm going to give myself a little bit of things to work with here. I'm going to draw a line, and I'll do, let's see, let's do a little push and pop here. So we'll do a line at 50, and I'll start this at, let's start at 180 down to 50, 380. All right. Yeah, that's what I wanted. So this is a line that actually I'll pull it back up a little bit higher. Sorry, I'm just tweaking here. So this is a line on the left edge that I'm going to be using, and I'm going to be moving things from that line to another line here in just a second. But that's my first line, and I'm going to make a second line. I could do this with the edges of the sketch, but I thought it might be it might get better visualization if I do this with lines that we can actually see here. So I'm going to do. I don't know, I'm getting ahead of myself a little bit, but bear with me. Okay, so my sketch goes 600 wide, so that means same deal basically, but at 550. So I'll go ahead and just copy and paste that line and add a couple fives here. And so there's my kind of starting line and finish line as we think about something moving from one to the left. So my vision for this, what I'm trying to create here, and what I hopefully will be able to create with the map function is, think of this as the start line on the left, and then as we move through the hour, through the minute, through the second, we're going to move from that starting line all the way over to the finish line. And what I want to be able to do is draw a circle at any given time using the draw loop that indicates what the current time is. And it should be as far along that race course as the seconds are towards the next minute, and the minutes circle should be as far along the race course as the current minute is on its way towards 2 a.m. as I'm recording this. So that's the idea. So to do that, we have to actually use something pretty cool called the map function. So I'm going to go ahead and just enclose my push and pop there to draw those lines. Probably don't really need these, but I've found them useful, so I've been putting them in by habit now. This just lets me isolate a bit of drawing instructions here. And yeah, I don't think I'm going to need those. But they're there, and I'm not going to take them out. So what we want to do is draw a circle. So I'm going to go ahead and just, I'll make I don't know if I need to declare them. I guess I will. So I'm going to say I call it x hour equals 0. Yeah, so we just need x's because the y's are going to be constant for each of these. So I'm just going to call that let x hour, and I'll do let y hour. No, I'll do let x minute equals 0. Let x second. And I think I'll just use these three things at least for now. And so what I want to do is draw these. Actually, since these I know start at 50. I'll go ahead and do that. And then I'm going to draw my instructions. I mean, my line is at my far left line is at 50, so I'm going to go ahead and draw some instructions that are just going to draw those in place there, and then it'll change that. I'm going to be changing these values, these x values, using the map function in a second. So let me draw first. Draw the circles. So do one circle. I'll go ahead and set the. Yeah, I think I do want push and pop here. I don't need it, but I think I'm going to put it there anyway. I'm going to set the fill to a nice dark gray. That might not be dark enough, but we'll see in a second. And I'm going to put the first one here at circle X, and as far down as 180. And I'll make this a 30 or 40 pixel circle. Let's see how that looks. What am I missing? Oh, what did I call it? Circle X. And I'm tired. Okay, so X. We'll do the hours first. X hour. So there we go. Go ahead and turn off. Forgot to turn off the stroke. So I'll leave stroke on for the text and the lines, but I'll turn it off within my little thingy here. So good. Okay, so this is now one circle just being drawn, currently representing the X hour, and I'm gonna just make some similar statements here for X minute and X seconds. Now I am going to be changing these before they get drawn, but just to kind of make sure they work, let me go through this for a second. So 180, actually I need to change my Y value for each of these, so it's not 180, it's 210, I'd say 220. I'll go a bit more. Yeah, that's good. And then I'll go not 280, but 300 maybe. Okay, so yeah, so now I have three balls, three circles at the starting line, and I'm going to move them across according to the current disposition of the time of day, as you can see it changing here. The time of night as it's changing here. So what I want to do is, like, I don't want to print X hour with, I don't want to use X hour with its current value or its initial value of 50. I want it to calculate a new value for X hour according to what the current time is. So I'm going to do that this way. I'm going to do X hour. I'm going to assign it. Hopefully this is coming through at a pretty clear. Zoom in a little bit. So I'm going to say assign value to X hour using map. So that's what I'm about to do. So X hour is going to be assigned to something that will be the result of the map function, and the map function is expecting 5 arguments. So it wants to know, first of all, something incoming, something that is changing, something that's coming from somewhere else. In this case, it's the current results of the hour function, which is, I know is going to be 1, but I'm writing my code in a way that I don't need to know that. I want it to know that. So that's coming in as 1. Now, the hour can be as low as 0, because it was 0 hour, 40 minutes ago. It can be as high as 23, which is what it would have been the hour before that. So I know that this is going to be on the range between 0 and 23, and that's the first part of the map function. It reports, you give it 2 numbers that are matching the low end and the high end of the incoming. Scroll up here a bit. Let me give myself a little bit of room so I can see it better. So I know that hour is going to be between 0 and 23, so I say the next 2 numbers are that range that I expect that to come from, to be in when it's incoming. Now I'm going to interpolate that into a new range. And that's something that I know that I want to place this, some path I want to place this along numerically. So I know it can be as low as 50, that's where it is initially set on that starting line, and I know it can be as high as, what did I say, 550, that's where my finish line is. So it's going to be somewhere between these, and the place that it is should correspond to, or should be similar to 1. So it should just be a little bit in from the starting line, a little bit to the right of the starting line. Yeah, there it goes. It's on its way. So yeah, not very far past that, but it's what I expected because that's the current time. And you know, one of the kind of challenges with this is it's sort of hard to debug this in the sense that I can't pretend it's a different hour and then see what the result is, except I can type it in and see, and hopefully that reports the same thing. So, you know, at 5 it'll look like that. At 20 it'll look like that. But of course, right now it's not that. It's 1. So okay, so there's that one. And let's try the same idea here. So let's assign value to x minute using map. So now it's the same idea. X minute is, did I spell it right? Yeah, x minute and map. And again, map, the first thing it wants to know is something incoming, something that I don't know when I'm writing this code that I know is going to be changing, and that's the results of whatever the result of the minute function is at the time that the draw loop is being run. So I know that minutes can fall between 0 and 59 because that's the number of hours in a minute, starting with 0 as the first one, counting 60 times, so we get to 59, 0 to 59. And again, the range for this one in terms of the interpolation, in terms of where I want to see it on the sketch, the low end or the starting line is 50, the high end or the finish line is 550. So when I run that there, I can see that I'm quite a bit farther along on this one. And if we see, yeah, if I wait another, 25 seconds or so, I will probably see that tick over just a tiny bit, a 60th of the way across from left to right. It might be hard to see, but I do want to just kind of pause a second, or a pause for about 10 seconds here and watch this happen to make sure that it is doing what I think it is going to do. Well, there it goes. Okay, good. There was a little bit of suspense there, but I was pretty confident that was going to work. So that's my minute thing. So let's try it for seconds, and this one obviously will, move quicker in a way that will be a lot easier to verify quickly. So same idea here using map. Second equals map, and then map is going to be taking second as the incoming value that I know, again, 60 seconds in a minute, so 0 to 59 is the incoming range of that, and then the outgoing range or the interpolated range is going to be between 50 and 550 again. And so if I move that along, you'll see that guy marching along his path and getting to the finish line, pretty quickly. But as you'll see, he's not going to get to the finish line and stop. Hopefully, he's going to jump back to the starting line and do it all over again. Clocks are cycle. Time is a cycle. All kinds of rhythms in our lives follow cycles. They start and stop, and then they start again. And sometimes it's a new day, a new thing, a new cycle beginning. Sometimes it's the same thing over and over again. That's the nature of time. That's how things work. Can't do much about that. All right. So I'm next going to do the thing that I mentioned with milliseconds. I'm actually just going to be looking at and copying in some code from another example I have, because it takes a while to kind of work my way through it. Or I don't know, maybe I'll be able to talk my way through it as we go here. But the problem is that, like I said, milliseconds, as I showed you earlier, millis doesn't give me the number of milliseconds since the last second. So if I needed any kind of animation like I have here, let's say if I wanted a millisecond circle to start here and then shoot across there, left to right, and then come back again, and left to right, come back again, left to right, come back again. I can't use this number, 15,000, 16,000. I can't use that in a map function because there's no repetition to that range. It's not going to be between 0 and 1,000. It's going to be between, it'll be just 0 and infinity. So I don't know if it's ever going to stop. So I can't use the map function that way. And there's other problems with it too. Like I can't, you normally wouldn't illustrate milliseconds, but let's say I wanted to have a smooth transition. Like, so this second counter's like ticking along. What if I wanted to have it move more gradually between each second? Maybe pulse every second, but move between those pulse points or something. In order to have that between, I would need to know how many milliseconds has it been since the last second. And I can't get that with this information. So there is another way to do it. It's not another way, but it's a technique. So let me pull up some of my code here. So I'm pulling up my notes here so I can keep track of it. Okay, so what we need to do is basically reconstruct or construct our own current millisecond function. So I want to get something that does what second does, but for milliseconds. So I'm going to need to create a couple of things, a couple of values that should be helpful as I do this. So sorry, moving my windows around. I know you can't see any of these. All right, so first of all, we're going to be keeping track of seconds as they tick over. So I'm going to make a variable just called current second. And what I want to record, or the moment I want to capture, is when does that current second tick over, right? So once it's a new second, I want to know, oh, I need to do something to the milliseconds. I want to reset the millisecond counter every time the second is the new second. So if I set that to just 0, to begin with, just to initialize it, and then down here in the draw loop, so remember the draw loop is the thing that's running and running and running and running. What I want to do instead before I do anything with milliseconds is I want to find out, is the current second, which is the, like I said, 0, right? So it's set to 0. Is that the same as or different from? And I'm using the different from operator here, the exclamation point equal sign, which means not equal. So is the current second, actually I got a typo there, is the current second not equal to the results of the second function? So remember, second function is returning 42, 43, 45. So this will be, this statement will be true initially because it's true that those are not equal. There will be one brief moment where they are not, 1 second where they're not, but because they will be the same, but not for long. And I could also just initialize this with a null value too, just to make sure that that doesn't ever end up being true. So this is something that, since the draw loop's running 60 times a second, this is something that will trigger just as soon as the second value returns something new. Just the millisecond after it should turn that over. So that means that we now have a new second to deal with. So let me add some comments here. Check if we have a new second. If we do have a new second, we're going to save that value so that it will continue to believe that it is the same second for the duration of the second that we're on right now. And then we want to capture whatever the milliseconds are. And this is something, in order to facilitate this, I found it useful just to make a temporary, not temporary, but like an external counter for milliseconds. So I'm keeping track of kind of where we are in the millisecond progress. So it's just kind of taking a snapshot. So the millis function is going to be returning however milliseconds, whatever it is. I just want to record, okay, what was that right when the second ticked over, like we just saw it do. So I'm going to record that, save that in the value, or assign millifreeze that value of whatever millis currently is. Okay, so then as the seconds actually go on, for the rest of the sketch, I can do something, and I'll just call it, I'm going to call it mm, and this sort of stands for my millisecond counter, but it's shorter, so that's mm. So my mm is going to be something I can calculate by assigning it the value of mm, of the current milliseconds. Oops. Let's be able to see this. So I need to assign it using the equals sign there, and it's going to be whatever millis is up to by now minus the last time we had a new second, which is what was recorded in millifreeze. So that's a quick way to get it. Now there's still something I might want to do here, but let's see how this looks. I'm going to go back to my function here where my debugging area, where I initially just was reporting the value of millis, which as you can see is sort of out of control. But if instead of that I use the millis, or the mm, my millis, you'll see that it's counting up to 999, I guess, and then resetting. So it's counting up 1,000 times and then resetting and then resetting and then resetting. So this is now actually, this mm variable is now giving me something that's a lot like what these other time-related functions are doing, which is possibly pretty helpful. So let's just, for fun, let's see what it would look like to make something similar to these other circles, but moving at the speed of milliseconds. So let's draw it here. Okay, so xmil equals map. And mm is the number now that I'm checking for, that I'm using to plot along the left to right course. I can already tell this is going to be a little crazy. I know that that can be as low as 0 and as high as 999. And I'm going to plot it between 50 and 550, just like we did before. I hope my text is big enough, by the way. I'm always kind of self-conscious about that, but I'm hopefully recording this at a high enough resolution that you can zoom in if you need to. So xmil, and then I'm going to draw that circle using xmil, now that I have that at a position of, let's say, 350. And I'm going to make this a smaller one because I feel like it. So let's see how that looks. There it goes. Okay. Yeah, so moving quite a lot faster than its peers, but you can see that it's moving smoothly, it's moving along that, and it's resetting its position every time. I don't think this is a particularly useful or good looking clock, but this is something like a clock. You know, if I were to think of this as a novel way of conveying time, of course I would want to disable the time printing and just kind of look at that. And I don't think this would be very useful. I don't think I could look at that and immediately tell you what time it is. But maybe that's not the point of a clock. Clocks aren't always all about accuracy. It's just about the sense of time passing, and that's what this conveys. I don't think this is a particularly aesthetically pleasing clock either. The main purpose of this video and the sketch really is just to demonstrate how these different functions report the time, and then how you can use what they report with the map function, which again, really the map function is more interesting, more useful, more important than the time function. I just think if you want to do anything interesting with portraying time, you are really going to need to use the map function. Okay, so kept this under 30 minutes. That's not bad for something this late at night. I tend to ramble on and take longer when I get this tired, but I think we're done. So thanks for watching this video. If you have questions as you're working on your time project, of course, please ask if you have questions. What I recommend to my students working on this project is draw it by hand first, like sketch some stuff out, try a bunch of different things and see what makes sense to you. Try drawing that thing at different states in different parts of the day. If it's going to change throughout that day, come up with something original. Try to avoid printing the time to the screen. Try to avoid polar views that kind of turn around a circle. Try to avoid anything with a clock face on it. So you're really trying to break out of those metaphors, which I know are deeply, deeply entrenched metaphors, ways of thinking about time, but you're trying to find a new one here. That's your challenge as a designer and as a creative coder. So I really look forward to seeing what you come up with. And if you come up with an idea and you're not sure how to get it working, that's where I can help. So please ask me for help. I love that question of, you know, here's this thing, I don't know if it'll work. You know, I may not know either, and we'll figure it out together, and that's great. That's my favorite thing in the world. So, well, my favorite teaching thing in the world. So thanks for watching this video. If you have any questions, if you need any help with anything, let me know. And happy coding.